got some fun data sets to play with. Those are the quizzes. We'll do those later. It's the sample average. Sample average. Anybody need a data sheet? You can move back there, Rory. Here we go. Anybody else need one? Here we go. We good to go? All right. So you've already exhausted, I think, the weight loss data. This is we were playing with this one about a week ago, and I think we got the point. And there was a big point in the weight loss thing we didn't even talk about yet when I asked about these standard deviations. So we'll come back to that in context of this. And the only reason I know we can do that is because I just did it with the other class, and it works out pretty nicely. It tends to fall right in. I went ahead and grabbed the 2013 Portland Marathon, and I defined a few terms. I called some finishers top finishers, and since I've done this, I've forgotten why I called them top. I think it was top 25%, maybe, like in the race, the top 25%, and the bottom 25%. And I randomly selected some ages of finishers. I ignored the genders. Somebody asked me that in the last class. Well, how about male versus female? I said, that's a fantastic question to look at the differences, but I wanted to keep this single variable, just age, not age combined with gender, because that would essentially double the number of categories. But I didn't want to do that yet. We'll do it soon. I'd like that. But so what we have here is see if you can make sense of the data. I try to also make it concise by making one kind of horizontal distribution. When it says number in top 7, and then above it is 15 to 24, can you interpret that for me? Make sure I understand what that means.
There were 7 people ages 15 to 24 that finished at the top.
Boom! In that top, and I think I defined it as top quarter, 7 people in my sample were between 15 and 24 years of age. Fair enough? Good enough? So 44 between 25 and 34, and so forth and so on and so forth and so on. Fantastic. Same thing with the bottom. Well, not the same thing, same designation of ages, but different allocations. Here's what I want you guys to do. I want you to analyze this data and try to tell me, is there any difference in ages between the top and the bottom? In other words, on average, is there any difference in average age of a top finisher versus a bottom finisher? Sarah's nodding her head, good, good. And I want you to quantify it for me. How much of a difference is there? Okay, yes, there might be, no, there might not be. If there is, quantify it. How much of a difference is there? So how are we going to do this? Yes, grab for technology. We like technology. Or a pencil. So here's what I want you to do to make life easy. The difference between this and what we did last week is that last week we had raw data with the weight loss guys up here. We now have grouped data. It's in a distribution. So here, to make life easy for ourselves, let me ask a question first. Where's the data? What's actually the data we're interested in? Yes, it's got to be the ages, because think about what I just asked you. Is there any difference between the top and the bottom age on average? So your data is going to be the age in years. So let's put that in L1. That's going to be your data in L1. Okay. Now you know you can't put 15 to 24 in there, right? You can't put 15 to 24. We'll let you put one number. So what number should we put in? I would go for 20. Oh, hang on now. Let's not use 20. I don't think 20 is in the middle. I think it's 19 and a half, isn't it? Yeah, good. I think it's 19 and a half. Why do I care? This is a good discussion. Did you hear the discussion we just had? I said you can't put 15 to 24 in L1. You've got to put a single number to stand for the whole category. We've got to go between 15 and 24, but we have to go directly middle. So one vote was for 20, and then no, we had a vote for 19.5. Why is 19.5 better than 20? It's right in the middle, and why do we care? What if we go with a 20? So we'd be going 20, then 30, then 40, then 50, then 60, and suppose we were up by that half a year every single time? Say that again. We're going to have an under or over estimate depending on how you round. So in other words, we're going to assume everybody's a little bit older than they actually are. So use the 19.5, the 20, it looks like 29.5, 39.5. Got to do that. We're already losing accuracy a little bit by the fact that it's grouped. Don't lose more by rounding wrong. Does that make sense? And then L2 and L3 are the frequencies. So run your top numbers into L2 and your bottom numbers into L3. Take some time right now. I'll do it too on mine.